Hi, this is Marwa, and this is another video about quadratic functions. We have had multiple videos before when we discussed the quadratic functions, their graphs, quadratic functions in vertex form, standard form, and how many solutions could there be for a quadratic function. Today we will actually discuss how do we solve quadratic functions by factoring. So we will only focus on factoring. We'll solve multiple questions for you to see the different types of factoring you could get. So let's look at our first slide here. It says here solve each equation by factoring. Well, if you're solving in the SATs, no one will ask you the question that specifies which way actually to solve. But we will learn factoring because sometimes it's the easiest way to use. We have here x squared minus 4x equals 0, so we are supposed to find the number of solutions. As we said, we have to make it equal to 0 because we are looking at the x-intercepts, or the points, values of x where y is equal to 0. In these two examples here, we will solve by taking the greatest common factor. I have x squared minus 4x equal to 0. I can definitely take x as a common factor. When you do that, you will have left x minus 4, and that's equal to 0. Now, if you multiply two quantities and get 0, one of them has to be 0, or both of them actually have to be 0. So it's either that x equal to 0, the other solution would be x minus 4 equal to 0. If x minus 4 is equal to 0, that means x is equal to 4. So how many solutions we have here? We have x equals 0 and x equal 4, and we did solve this equation by factoring. Let's look at another one. Again, we're going to use the greatest common factor. I have 6x squared plus 4x equal to 0. Between 6 and 4, I can take 2 as a greatest common factor, and I have x squared and x. I can also take x as a common factor. What is left is 3x plus 2. How do I know? 6x squared divided by 2x. 6 divided by 2 is 3, and x squared divided by x is x. 4x divided by 2x is 2 equal to 0. Again, as we said, 2x equals 0 and 3x plus 2 is equal to 0. In this case, divide both sides by 2, you'll get that x is equal to 0. So this is one of the solutions. So if I have a parabola, it will intersect with the x-axis at 0. And here I have 3x is going to be equal to negative 2, which will make x equal negative 2 over 3 when you divide both sides by 3. I've solved each equation by factoring again, and we have a trinomial. When we factor a trinomial, we know that the first terms here has to be two terms that when I multiply them, I get x squared. So I have x and x. Now these two terms are two numbers that if I multiply together, I'll get 8. So 8 here is the product. And if I add them together, I'll get 6. So 6 here is the sum. So I want two numbers that would have a product of 8 and they will add up to 6. So definitely 4 and 2, and both of them are positive. So I can say here that x plus 4 is equal to 0, as we said, or x plus 2 is equal to 0, which makes x equal negative 4 and x equals negative 2. Okay, what about this one? I have b squared minus 4b equal to 21. We cannot factor like that. It has to be equal to 0. So this is going to be p squared minus 4p minus 21 equal to 0, and we factor again. I want two numbers that I would multiply together to get negative 21. Well, if it's negative, then definitely they are of opposite signs. Here, because the product was positive, so I knew both of them are of the same sign. And when I add them, I get a positive number, so both of them has to be positive. In this case, the product is negative, so I want two numbers of opposite signs. Now, these two numbers are going to be 7 and 3. 7 and 3 will add up to negative 4 only in the case the 7 is negative and 3 is positive. Negative 7 times 3 is negative 21, and negative 7 times 3 plus 3 is negative 4. So again, the constant is the product, and the value of b, or the number multiplied by the middle term, is the sum. So again, I have p plus 3 equal to 0, and p minus 7 is equal to 0. So p equal negative 3 and p equal positive 7. These are the solutions for this function. These two cases here. This is what we call a perfect square trinomial, and this is what we call difference between two squares. Now, perfect square trinomial, before I show you what that is, we can just factor it normally. So I tell you why do we call it a perfect square trinomial. Now here I get x, and I want two numbers. When I multiply, I get positive 25, but if I add, I get negative 10. So that's definitely negative 5 and negative 5. Now, because both factors are the same, this is why we call it a perfect square trinomial. I can write it as x minus 5 squared equals 0, right? Because this parenthesis is multiplied by itself. Why do I do that? Because this will give me only one solution, which is x minus 5 equal to 0 if you square root both sides, which will make x equal 5. So this function here will give me only one solution. If I use a discriminant, as we said last time, we will know that this will give you one solution, okay? Because the discriminant, the value of the discriminant will be 0. If you want me to show you, well, the discriminant, if you remember, I'll link it for you up here, is b squared minus 4ac, and b squared here is going to be negative 10 squared minus 4 times 1 times 25. Negative 10 squared is 100, and negative 4 times 25 is minus 100, which is equal to 0. We said if the discriminant is equal to 0, so there is only one solution. When we factored, we found only one solution. Okay, what about this case here? Now, you can just say x squared equal to 9 and square root both sides and get positive and negative 3. This is if you're solving this just as an equation and by isolating the variable. But if you are required to factor, this is a difference between two squares. Actually, when you see a quadratic with only two terms like that, one of them is x squared and the other is a constant, and there is no middle term, and this has to be negative, you know that this is x plus 3 and this is x minus 3. So x squared is x and x, and the 9 is positive 3 and negative 3. Why? Let me show you why before we continue factoring. Now, if I multiply x plus 3 by x minus 3, what will happen? X times x is going to be x squared. We're just using distributive property. Then minus 3x and plus 3x, then minus 9. What did we do? X times x is x squared. X times negative 3 is negative 3x. Positive 3 times x is positive 3 minus 9. When you simplify, you will find that negative 3x plus positive 3x, these will cancel, and you're left out with negative x squared, minus 9. So this is what we call difference between two squares. You are multiplying two factors. Both of them have the same terms, but one of them is a sum and the other is a difference. One of them you're adding and the other is subtracting. Because of that, and because they have the same constant, both of them, then when you multiply, the middle term will cancel out and you'll get that. So once you see a quadratic equation with no middle term, and this is a perfect square, or even if it's not a perfect square, we'll just use radicals, but with this is a perfect square, then this is difference between two squares. Now this will end up as x plus 3 equal to 0, or x minus 3 equal to 0. So your answers are x equal negative 3 and x equal positive 3. So we did solve by using a common factor, we did solve by normal factoring, and we do know special cases. The special cases are that this is a perfect square trinomial, we only had one solution, and that this here is a quadratic but it's not a trinomial, and you can factor it by what we call difference between two squares. I'm gonna solve with you here. I'm using a method that I'm not sure if you're familiar with. As you can see here, now this case, the value of a is not 1 anymore. We have a value of a that is a constant. So actually factoring here is not as easy as it used to be. Let's first of all put this in the form we want to. So I have 3x squared minus 16x minus 12 equals 0. And why are we doing this? For us to be able to factor. Now, Actually, it's not easy when you have a number here to factor. You can use trial and error, which most people do to solve, but I want to show you something else. I'm going to use something that I call slide factor divide. What do I mean by slide factor divide? I am going to change this into another equation that I am going to solve and work on to get the answers. The first step is slide. What do I mean by slide? I am going to move the 3 and put it up here by multiplying. So I'm going to have x squared minus 16x. Then I'm going to multiply the 3 by negative 12, which is negative 36. Now, this is not the same as this one. However, I'm going to use it to find the solutions easily. Okay? Now, I'm going to factor this normally. Now, which two numbers do I multiply to get negative 36? And if I add them, I'll get negative 16 and these two numbers of different signs. Well, it's negative 18 and positive 2. Negative 18 times positive 2 will get you negative 36, and if you add them, you'll get negative 16. Okay? Now, what I have done now, I changed this equation into a different equation. I got rid of the 3 because it will make my life miserable, and I found this. This is the solution. These are the factors of this equation, but they're not the factors of this equation. If I want them to become the factors of this equation, I'm going to do something else. I slided, I factored. The next step I'm going to do, I'm going to divide. So this method is slide, factor, divide. What am I going to divide? I'm going to divide these two numbers I found by the constant I moved. I divide here by 3, and I'll divide here by 3. So what would you get? You're going to get x minus 18 over 3, which is 6. And here you're going to get x plus 2 over 3. Okay? Now, if I want to write this in a better way, I'm going to just move this here. So I'm going to get x minus 6 times 3x plus 2. These are the factors of this equation. Now, you can use trial and error to find it, which is the method that most people do, or you can do this. Now, why do I find this easier? Because I only learn one type of factoring, the one that I have used all the time, where a was, or the leading coefficient was equal to 1. Then I'm going to use a little trick to get the factors. Now, actually, I can stop at this step if I want the solutions. If I don't want the factors, if I want the solutions, I can stop at this step. And I can tell from this step that x is equal to 6 and x equal negative 2 over 3. So from here, I can stop here and cancel this and only get the solutions if I am solving a quadratic equation. If I'm only factoring, I'm going to just move the denominator in front here to get this solution. I'm going to do it once more here. But before I do it, just take in consideration that there is a common factor here. Always look for a common factor first because it will make your life easier. I have 18x squared minus 33x plus 12. All of them are divisible by 3, so I can take 3 as a common factor. I am left with the 6x squared minus 11x plus 4 equal to 0. Now, I'm going to ignore the 3 completely and work in this part here. What am I going to do? I'm going to do what I did a minute ago. I am going to use slide, factor, divide. I'm going to multiply the 6 by the 4. So it's going to be x squared minus 11x plus 24. And this should be equal to 0. I'm going to factor this. As we said, it's not the same equation, but it helps you find the solution. I have x, and I'm looking for two numbers that I multiply together, get 24, and add, get negative 11. So both of them has to be negative to give you a positive sum. And these are going to be 8 and 3. Okay? Now, what am I going to do next? What I said. I slided, I factored, I'm going to divide. What am I going to divide by? I'm going to divide by the number that I moved here. So I'm going to divide this by 6 and divide this also by 6. For this to work, you have to simplify. So this is x minus 4 over 3. If you don't simplify, all your work is wrong. And this is x minus half equal to 0. As I told you before, you can stop here if you don't need the factors. So I can tell that x minus 4 over 3 is equal to 0, where x is equal to 4 over 3. This is my first solution. and x minus half is equal to 0, so x is equal to half. Now, if you are not looking for the solutions and you want the factored form, I'm going to use a completely different color. What are you going to do? You're going to just move that 3 here. So the factored form of this is 3x minus 4 multiplied by 2x minus 1 equal to 0. Okay? And if you can check by multiplication and see if you're going to get this or not, and it will prove for you that this would work. So I'm going to have 3 here, and let's just start multiplying. 3x times 2x is 6x squared, and 3x times negative 1 is negative 3x, and negative 4 times 2x is negative 8x. Then negative 4 times negative 1 is positive 4 equals, when you simplify this, and don't forget the 3, I'm going to just have to write here, this is going to be 3 times 6x squared, negative 3x and negative is negative 11x, plus 4, no space to write. Then you're going to distribute and you will get 18x squared minus 33x and plus 12, and this is just for checking your work. Okay? So this method, which I call slide factor divide, make it easier to factor when you have a leading coefficient that is not equal to 1. So if this number here is not equal to 1, the other method you can use is trial and error. Actually, you can try the 3 and factors of 3, and you're going to try the factors of 12 and see how they work. There is a third method which is different than the ones we have, but we're gonna stop here. I hope this has been helpful for you, and thank you so much for watching.